Hello everyone. I got a request to do problem 35, 37, and 39. So I think I'll do each of them in a separate little video and post them separately. But for now we have 35 showing, and the directions are to find the derivative of f of x at a equals -2. So we have to remember that the derivative is the slope of the secant line, and then we take a limit as delta x approaches 0 to find the slope of the tangent line. So here is my equation. F prime at -2 equals the limit as delta x approaches 0 of f of -2 plus delta x minus f of -2. That's my y2 minus y1, and then over x2 minus x1 on the denominator. And now what we have to do is take each of these x values, plug them into the function to get the y value. So that will look like we'll put -2 plus delta x into the function and get -2 plus delta x plus 3, whoops, almost messed that up, plus 3 minus f at -2, sorry about that guys, been a long day. We'll have 1 over -2 plus 3, and all of this is over delta x. Alright, so I'm going to simplify that up. It'll be 1 over, that'll be 1 plus delta x minus 1 over 1 divided by delta x. And now I'm going to get a common denominator in the numerator. So that common denominator is going to be just 1 plus delta x. And so this guy right here will just stay a 1. And this guy right here, I'm going to have to times by 1 plus delta x. Don't forget your parentheses because that negative is going to have to distribute. And then instead of dividing by delta x, I'm going to times by 1 over delta x. Remember, when we divide, we flip and multiply. All right, so now I'm going to have to come up to the top here. We have, let's see, the limit as delta x approaches 0. And that'll be 1 minus delta x. So that top is just going to be minus delta x all over 1 plus delta x. And then times the 1 over delta x. From there we can cancel the delta x's. And we're just left with -1 over 1 plus delta x. If I take that limit, I can evaluate it by just using substitution. So I'm going to get a final answer of -1. So the slope of my function that I was given at -2 is -1. And just as a side note, if I wanted the equation of the tangent line, I would need my function value at -2. And if I plug in -2 to my original function, I'll get the y value. I need my slope at -2. The equation of my tangent line is y minus y1 equals m times x minus x1. So that equation then will turn out to be y minus 1 equals m times x minus x1, which will make that a plus 2. So that would be the equation of the tangent line. Hope this helped.